Alright, so here we are with the Chapter 2, Section 3, Day 2 notes. And our objective is to find the zeros of a polynomial function. So, when we talk about finding the zeros, we're talking about roots, x-intercepts, solutions. They're all referencing the same idea. It's where that function, if you were to graph it, would go through that axis. Alright, so we're trying to find all of those, and of course that's why, for instance, they're called zeros, because technically we are in fact looking for when do we get a zero for our y value. Okay, we also have here in number 1, we're looking for a root, because a lot of times what happens actually is that when you are solving, you end up using a square root to get there. So that's kind of where that root idea is. And then we also have an x-intercept, because clearly it's going through the x-axis. And let's see, roots, zeros, got it, x-intercepts, and solutions. Because technically, if you were to set it equal to 0, this would be where you solve to get a 0. So either way, as many names as they have, we are just looking for those intercepts there. I usually call them intercepts, but alright. So let's go ahead and find some zeros algebraically. So basically anytime that you have a squared, we are looking for that idea of what multiplies to be 28 and then adds to be negative 11. And those two numbers, whatever they may be, are going to go into these factor pieces with x and then plus or minus that number. So depending on how you do this, I do use kind of this area model. And so the idea would be that you take x squared, negative 11x, and 28, your initial trinomial, plug it into the sides there. And then as you look for what multiplies to be 28 and then at the same time adds to be negative 11, those two pieces will end up in here with an x. So we're going to go through and find our multiples of 28. So 28 can come from 1 and 28 and then also negative 1 and negative 28. We also have negative 2 and negative 14 and then 2 and 14. Let's see, does 3 go in there? No, but 4 does. 7 times. And then we have negative 4 and negative 7. And we already did 2. So that's it. Okay. So now we're trying to find out which ones add to be negative 11. So that's these guys here. So negative 4 and negative 7. And really the only reason that we have this negative 11 here is so that you can see that that should come from the two pieces that you put in to be add to it. Alright, now we get to go for the fun part, and this is especially helpful when you are trying to do something with a leading coefficient that is not 1. So if a is not 1, this is a very good technique for that. Otherwise, because a is in fact 1, we can actually just put in negative 4 and negative 7. But just in review, if we were going to have a number out front there, that leading coefficient that is other than 1, we would find the GCF of this first column, which is x, the GCF of this second column, which is a 7, and the interesting part about negatives is that you could or could not put them, and so I'm going to actually take it out. Anytime that you have one negative, you just risk, are you going to need it or not? So, negative 7, and then this top row here definitely has an x that can come out of both of those, and then the bottom row has a negative 4. And so as you can see, we do actually end up with the two factors of x minus 4, and then also x minus 7. So again, this is our factor completely, and so from that, our zeros are when you actually set each of these equal to 0 and solve, which means that our 0 is going to be 4, 0, and then also 7, 0. Alright, so those are our zeros. Alright, the next one here is actually going to look into the fact that we are going to end up using the box and then that second method that we were doing in the previous example. So just a reference to, do you know how to factor? So the first thing before we start factoring is going to be our y-intercept. Very nice. Basically you have your a value here, b here, and c, and your y-intercept is just 0, c. So in that case our c value is 1, so 0, 1. Alright, then we're going to find the x-intercepts, or the zeros, or the roots, so that's the second part here, and so in order to do that, all we would need to do is factor. So if we factor, we're going to end up with negative 6x squared in that top piece. We also have a 1, and then technically in the middle here is going to be our 5x. So what we need to do is find all the factors of negative 6 times 1. So we need the factors of negative 6 that are going to add to be 5. So negative 6 comes from negative 1 times 6, or 1 times negative 6. And then we also have negative 2 and 3, or positive 2 and negative 3. So looking at becoming a positive 5, it looks like we're going to need positive 5, this one here. So negative 1 and 6 are our pieces with an x. And now we get to take our rows and columns and find the factors. So looking at this first column, definitely both have a negative, and then they both have an x. Otherwise there's not much of a GCF there. Greatest common factor. Then this next column we have 6x and 1, and so sadly the only thing that comes out of both of those is a 1. And then for this top row, definitely a 6 and an x. And then for this last row, again, only a 1. Always want to double check to see that it actually works. So for instance, 6x and negative x does make that factor. 6x and 1, and negative, yep, okay. So it does work, which means that this factored is going to be negative x plus 1 and 6x plus 1. So if we go ahead and find our x-intercepts, the easiest way to do that is to set each of them equal to 0. So if we set, let's see how much room I have, 6x plus 1 equal to 0, we get subtracting a 1 to both sides, and then dividing by 6. So technically our x-intercept is going to be negative 1/6, 0. So definitely couldn't have done that by just guessing. And then the last one is negative x plus 1, set equal to 0. So x is apparently 1 in that case. Alright, then we look for our end behavior, and so hopefully we remember the ideas from our previous lesson, which was if we have this negative out front for our a value, that's going to mean that it, I believe, begins, let me double check. Nope, right, it's called end behavior, so this negative out front would mean that the negative ends down, but then also the fact that it's a squared or an even power means that the beginning ends down as well. So if we write it in our end behavior notation, we're going to say that the limit as x goes to, in this case, the right, either way, of the function is down, and then we can also say that the limit as x goes to negative infinity, or to the left, of the function is down as well. Alright, and then this last piece is your extrema, or your minimums or maximums. And so in this one, since I know it's a squared, the only way that I can get to the minimum or the maximum, or the vertex in this case, is going to be by using the fact that your x of your minimum or your maximum is equal to negative b over 2a. If this was going to be anything other than a power of 2, you would be going for graphing. Otherwise, you're not going to be able to algebraically figure them out right away. So our b value, as we said up top, is 5. So negative 5 over 2 times negative 6. Which means that our x value for the vertex is going to be negative 5 over negative 12, or 5/12. That's a lovely number, as our x value. And then we're going to take 5/12 and plug it in to the equation up here for all of our x's. And so 5/12 will be squared, and then times negative 6. We'll also have 5/12 here, times 5, and then add a 1. So if we take the function and plug in 5/12, we're going to get our y value. And so if you put all your pieces together here, you're going to get your 25/12, which we will then, well, you also have a negative 2.5 and a plus 1. Kind of did that out of order, but either way, you're going to end up with 7/12 as your y value. So kind of a lot going on in there, but the idea is that to get your y-intercept, it's the last digit after you put in zeros for everything else. Your x-intercepts comes from factoring, but of course you could find them on a calculator as well. Your end behavior is based on this leading coefficient, so whatever it's talking about, negative for instance, your end is negative, versus if this was a positive 6, it would be a ending of positive. And then of course that even or odd tells you if the opposite end or start is the same if it's even, or opposite if it's odd. And then your extrema, your maximums or minimums, you're going to have to find it on a graph when the power is more than 2, but otherwise your vertex is technically at negative b over 2a, and then that result you plug in order to get your y value. Alright, so then we have our cubic function. And so when we ask about this one, it's asking us how many roots are we going to get. And so again, those are your zeros. And not only how many roots are there, but could you please factor them as well. So technically, because there are 3, there could be a maximum of 3 roots. Kind of just depends on all these other numbers that are involved in here, because the more that you have involved over here, the more it's going to actually make it kind of wobbly, versus the less you have over here, the more it's just going to make it that you would only have like one smooth curve with 1 root. Alright, so the first thing you're going to want to do in here is factor as much as possible, so we always look for the greatest common factor in all of them, and there's an x. Since there's a negative way out front, I'm also just going to take out a negative x so we don't have to deal with that. And so negative x way out front leaves us with x squared, minus x minus 6. And so now we're just trying to find out what is going to multiply to be negative 6 and add to be negative 1. So we need all the factors of negative 6, which I'm sure we could all go ahead and just guess which one it's going to be, but hey, wouldn't it be fun to write them all out? Okay. So, trying to find which ones add to be negative 1, that's these two. And so now our final, after going through and factoring all of them, is going to be a positive 2 and a negative 3. Which means that all of the zeros that come from it is, when is this equal to 0? That's at an x of 3. This is at 0 at an x of negative 2. And this is at 0, weirdly enough, at an x of 0. So that means that all of our zeros are going to be 0, 0, negative 2, 0, and 3, 0. Alright. The next one, they want you to factor using your calculator. It's an interesting way of doing it. So basically what's going to happen is you're going to use your calculator to find the zeros, and then the factors are going to be the opposites of those x values. So, When we use our graphing calculator, we're going to want to type this in here. Alright, so clearly because you have a 144 involved here, we are going to have a very tall graph because it's going to intercept at a y-intercept of 144. So either way, you don't really need that visual, because instead you can just do a 10 by 10 grid, and then you'll be able to see on your grid that you have one going up that way, and then down and up that way. Which means, and if you have good tick marks on there, that this one's actually at negative 1, 2, 3, 4, 5, 6. Over here we're at 1, 2, 3, 4, and then 6 for that one. Now if you can't see that from there, you can actually just press the trace button, and if you press the trace button once, and then you can actually just type your x value, that will allow you to double check. So for instance, I press trace once, and now I'm typing in -6, and then I press enter, and then it tells me that my y value is at 0. So you can always double check, because sometimes the visual on this looks like it's going through that, but of course it doesn't actually, so you do want to double check. So there's 4 and there's 6, again just typing those in and checking. So that means that my zeros are, -6, 0, 4, 0, and 6, 0, which means that my factors are going to be x plus 6 for that one, x minus 4 for that one, and x minus 6 for this last one. So that's it factored out. Alright, moving on. The next one is to find a cubic function with the given zeros. And we're going to check by graphing. So, notice it says a cubic, so they're not actually telling us what the leading coefficient could be, because pretty much every cubic function with these zeros can be multiplied by any number and it's still going to have those same zeros. So, in that case, they're not telling us necessarily what the intercept is going to have to be, so in that case, we are just going to go with the basics, which means that our first 0 is going to be x plus 2. Our second one is coming from the factor of x minus 3, and our last one comes from the factor of x plus 5. So very basic, it's just each of those as its opposite. So, the interesting part about that is that it doesn't look like a cubic function, and so we are going to actually want to expand that so that we do have something that's x cubed, and then all the pieces after it. So in order to do that, we're going to remember our either FOIL or our area method with the box here. So if I multiply these first two together, I'm going to get x squared, 2x, negative 3x, and negative 6. Or altogether x squared minus 1x minus 6. And then that is going to be multiplied by an x plus 5. So changing my box to a 2 by 3, I have x squared minus x minus 6, and then the other side is x and 5. Putting it all together, we get x cubed, which is what we want. Negative x squared, negative 6x, 5x squared, negative 5x, and a negative 30. Remember that the diagonals do end up going together, so these pieces will end up as our final trinomial, not trinomial, a cubic function of plus 4x squared minus 11x minus 30. And so I am going to put that into my calculator and just double check that each of those are zeros. So as I'm graphing, remember you press trace and then you can just type in negative 5. You can of course do this on the table as well, but it's a nice visual. Type in negative 2, yep, that's at 0, and 3 is at 0 as well. Alright. So we did go over this in Algebra 2, hopefully you did, wherever you went to School for Algebra 2, and so the idea here is that we're finding multiplicity. So, remember that a multiplicity really just means, especially if it's an odd power, that it's going to end up kind of having more of this snake-like piece at, in this case, the 2 value. And then over here, if it's a squared, that just means that it's going to have kind of a quadratic, as in it's going to hit that axis, in this case at -1, and then bounce back off. So, on that note, the degree in this is 5, which means that when it comes to roots, it's going to have at most 5. And of course, since x-intercepts are roots, again, we're going to have at most 5. So we're going to go through and actually find each of these. And see what's happening. Let's see. I guess I don't really need to go too far. So, the first thing that I'm going to talk about is the roots. It turns out that yes, there are at most 5, but because of multiplicity, there's actually only 2. So, 2 because there are 2 factors. And then again, x-intercepts is the same idea, but it, of course, is not 2. There is, sorry, not 5, there's 2. And then those 2 are going to be the opposite of the numbers that sat in there, which is what I kind of showed in that image. So one of the roots is going to be at 2, 0, and the other one is going to be at -1, 0. Alrighty. And all of that super fun quadratic cubic thing is going to be what you're going to do in your assignment. So we'll take the time to go through all of that in a little bit more detail.